Hello, so today our group will be presenting a topic for Organic Chemistry 2, which is aspirin or acetylsalicylic acid. So, before we start our presentation, I am going to introduce our group members. So, I am FATIN NAZIRA NASUHA binti Muhammad GHAZALI, and my group members is AFRINA, MURSYIDAH binti Muhammad TARMIZI, and INSYIRAH FATIHAH binti ABDULLAH. These are our presentation outline. We will start with introduction, then moving on to physical and chemical properties, benefits and uses of aspirin, chemical reaction, conclusion, and lastly, references.
For the introduction, I will be presenting about aspirin, also known chemically as acetylsalicylic acid. Aspirin is a synthetic derivative of salicylic acid, which is a compound found naturally in many plants. Many of the most well-known natural source of salicylic acid is the willow tree. From the salic genus, the bark of this tree has been used for countries in traditional medicine because of its pain relieving and anti-inflammatory properties. Besides the willow tree, another plant that contains salicylic acid is window sweet or Filipendula almaria. This plant has also been used historically for similar medical purpose. In plant, salicylic acid plays an important role. It helps with growth, development, photosynthesis, transpiration, and ion uptake. It also acts as a defined hormone, protecting plants from pathogens and environmental stress. It is synthesized by reacting salicylic acid with acetate anhydride, which produce acetylsalicylic acid and acetic acid as a byproduct. This process was first successfully developed by Philip Hormone at Bayer in 1967. Since then, aspirin has become one of the most widely used medication in the world for treatment pain, fever, and inflammation. Now, I will explain the structural formula of aspirin. The iupac name for aspirin is 2-acetoxy-benzoic acid, but we usually just call it aspirin. If you look at the diagram, you can see that the structure includes two important functional groups. The first one is the ester group, written as COOH. Is shown here is an acetyl group, which is O bonded to COCH3 attached to the benzene ring. Second group is the carboxyl group, written as COOH. This is a carboxylic acid group also attached to the benzene ring. Aspirin belongs to the homologous series of carboxylic acid and ester. More specifically, it is part of the aromatic carboxylic acid and aromatic ester. This type of compound have a benzene ring connected to both of carboxylic acid group and an ester group. Now, let's look at the physical and chemical properties of aspirin. Starting with the chemical properties, aspirin can get hydrolyzed when it comes in contact with moist air. It also decomposes easily in some solution. If we mix with air, it can be explosive under certain conditions. Medicinally, it is known for being anti-inflammatory, anticoagulant, and also analgesic, which means it helps us relieve pain. For the physical properties, its molar mass is 118.16 grams per mole. The melting point is 126 degrees Celsius and the boiling point is 140 degrees Celsius. Aspirin has a density of 1.40 grams per cubic centimeter and is also soluble in water.
Benefit of aspirin. Number 1. Prevent a second heart attack or stroke. Prevent clots from forming in blood vessels. Should take daily aspirin. Doctors recommend that even healthy people take a daily low dose aspirin to prevent a first heart attack or stroke on April 26. The U.S. Preventive Service Task Force finalized its recommendation against starting daily aspirin for primary prevention of cardiovascular disease in adult age 16 or older. American Heart Association states aspirin should be used freely to help prevent a heart attack and stroke. among adults aged 14 to 17 without no cardiovascular disease. However, these recommendations do not apply to people who have heart attack or stroke or have stent in an artery. Did you know that aspirin can also help during pregnancy? Actually, low-dose aspirin can lower the risk of preeclampsia, a serious condition in pregnancy that involves high blood pressure and can be dangerous for the mother and the baby. According to the U.S. Preventive Service Task Force, women who are at high risk of preeclampsia should start take low-dose aspirin after 12 weeks of pregnancy. Aspirin can protect the heart and even help during pregnancy, but only when recommended by a doctor. Aside from the heart protection and pregnancy-related benefits, did you know that aspirin can also help with fever? Yes, aspirin has antipyretic effect, which means it helps reduce fever. It works by acting on the hypothalamus, the part of the brain that controls body temperature. Aspirin helps lower the body temperature set point, so the fevers go down. But remember, aspirin should be used with caution, especially in children, and always follow doctor advice. Aspirin is known for its heart-related benefit, but did you know it has many other uses too? One of the most common use is for pain relief. It's an analgesic. It's great for the headaches, especially tension headaches and even migraines. It also helps with the muscle and joint pain, especially in conditions like arthritis or after muscle sprain. Moreover, it can ease toothache and even muscle cramp, or what we call dysmenorrhea. Aside from the pain relief, aspirin also has some miscellaneous use. For example, it's sometimes given after surgery to help prevent blood clots. And in people with polycythemia vera, a condition where the body makes too many red blood cells, aspirin helps lower the risk of clotting. Another major use is for inflammation reduction. That's why it's used in rheumatoid arthritis and osteoarthritis to reduce inflammation and pain in the joints. It's also helpful in conditions like bursitis and tendonitis, where it reduces swelling in the bursae and tendons. So overall, aspirin isn't just for the heart. It's a multi-purpose medicine with many important uses.
Alright, now let's talk about how aspirin is metabolized in the human body. When you take an aspirin tablet, the active compound, acetylsalicylic acid, is absorbed into your bloodstream. Inside your body, it undergoes a reaction known as hydrolysis. In this reaction, the ester bond in aspirin is broken down by water with the help of enzymes like esterase. As a result, aspirin is converted into two products, salicylic acid and acetic acid, which is a simple carboxylic acid. Salicylic acid is the main active metabolite. It is responsible for most of aspirin anti-inflammatory, analgesic, and antipyretic effects. Meanwhile, acetic acid is a byproduct. It's the same acid found in vinegar, and it's safely processed and eliminated by the body. So, in short, once aspirin enters our body, it's rapidly broken down into salicylic acid and acetic acid, and that's how it begins to relieve your pain and inflammation. Now, let's look at what happens when aspirin breaks down in the body, which is a process called hydrolysis. Aspirin, also known as acetylsalicylic acid, contains an ester bond. In the presence of water, especially under basic conditions like with sodium hydroxide, this bond can be broken. During hydrolysis, the ester group in aspirin reacts with hydroxide ions. This reaction breaks the ester bond, producing two products, salicylic acid, which still has the aromatic ring, both OH and COH group, sodium acetate, the salt formed for acetic acid, and sodium ions. This reaction is important because it explains how aspirin becomes active in the body. Once broken down, salicylic acid is the compound that gives the pain-relieving and anti-inflammatory effects. So hydrolysis is like unlocking aspirin's real power. Right, moving on to the next one, let's take a look at how aspirin or acetylsalicylic acid is synthesized in the lab. The process begins with salicylic acid, which contains both a hydroxyl group and a carboxylic acid group on a benzene ring. To make aspirin, we react salicylic acid with acetate anhydride, a compound that donates an acetyl group. In the presence of a catalyst like concentrated sulfuric acid, the acetyl group from acetic anhydride attached to the hydroxyl group on the salicylic acid. This forms acetylsalicylic acid, the active ingredient in aspirin, and acetic acid as an byproduct. This is an example of an esterification reaction, where an ester bond is formed between the phenyl group of salicylic acid and the acetyl group. After the reaction, the mixture is cooled and the aspirin product is typically purified by recrystallization, and that's how aspirin is synthesized, which is a simple yet elegant example of organic chemistry in action. So, for the conclusion, aspirin or acetylsalicylic acid is a widely used drug, known for its pain-relieving, anti-inflammatory, and fever-reducing effects. It works by inhibiting the COX enzyme, which helps produce prostaglandins that cause pain and inflammation. It's especially valuable in managing pain and preventing blood clots in cardiovascular disease. However, long time or high dose use can lead to side effects like stomach irritation or bleeding. Despite the risk, aspirin remains a key medication in modern medicine, with ongoing research aiming to improve its safety and expand its uses. So, these are our references. Thank you.